Guess it helps if I click the right thing to unblock the microphone, huh? Testing, 1, 2, 3, testing. I see green lights. I hear my own phone. I think we're good. I think we're live. We're doing it. We're doing the thing. Sick beats, bro. Okay, let's get rid of this screen, shall we? I mean, that's not the one I wanted, but no, oh god, stop it. That'll work. It's fine. Welcome. Greetings to you all. Welcome to our planetarium show, our live stream planetarium shows. It's been a few days. Had some fun issues around the house. Plumbing issues and things like that, so we've been away for a little bit, but I'm here to listen to you. Chat says I'm here to listen to your smooth, velvety voice. Oh yeah, baby. Just kidding. So, how are you all doing out there in the internet, wherever you happen to be? Messages and things coming in all at once. It's wonderful. All right. As we normally do, let's take a look at astronomy picture of the day and kind of catch up on some things. Again, if you are new to the channel, there's a viewer number on various streams. Remember, we are live streaming to Facebook and to Twitch and to YouTube all at the same time. I can see multi-stream chat. I just can't respond in chat to everybody at once because of the way it's set up. I don't know why. But stream chat does show up. Anyway, whichever platform you're on, please say hi so that I know I can recognize you in chat. And feel free to stop me at any point. Ask questions. Actually got a question earlier sent to me. That's a first. And so we'll address that question a little bit later. That question actually was about a giant star. And a red giant star. In fact, let me see if I can scroll back a second and grab that so that I can show you. It was actually a Wikipedia article that was sent to me. And the question was, how did the star get that big? So we'll be talking about star sizes and giant stars a little bit later. Let me actually add this to the listing of things we'll talk about. But yes, feel free to stop me at any point, anytime. It's good to see you in chat. It's good to see you in Facebook. It's good to see you wherever you are. I hope you are doing well. Let's hide our astronomy stuff there. There we go. Let's go to the more astronomy stuff. Let's talk about astronomy picture of the day. So, what is astronomy picture of the day? It is something that NASA runs. It's been around since 1995, so the archive goes back very, very far. We always start off with this just because it's usually something kind of cool to talk about, and then we'll jump into the planetarium. We'll talk about the moon phases. We'll talk about the Mars rover Perseverance. I got some star stuff that we'll be talking about a little bit later. So we got a full smorgasbord of things to talk about, but it also depends on what you, the viewer, want to talk about as well. So if you have any questions, feel free to stop me at any point, because unlike an actual planetarium, here you can stop me at any point. In an actual planetarium, if you raise your hand, I can't see you. It's too dark. So this is what astronomy picture of the day looks like. If you go to Google or DuckDuckGo or whatever, Bing, whatever you like to use, and type in astronomy picture of the day, you might get this link. And it looks like an old website, because it is technically an old website. Every day there's a new picture. Sometimes it's a video, sometimes it's a GIF file, sometimes it's just a static picture, or maybe it's got labels. Let's look back at just the last few days, just to kind of get an example. This was from, what day was this? This was the 2nd of April. This is the galaxy in a bubble, and that looks pretty cool. That's a spiral galaxy right here with the kind of a halo around it. Whenever you look at pictures like this, just as a kind of an aside, since we can click on it and make it bigger, you see these objects with the big crosses through them. That's diffraction from the camera, from the telescope that these are taken in. So these are actually stars, you know, big balls of gas and plasma in our galaxy. Our galaxy is the Milky Way. Thousands and thousands and millions of stars and planets, gas and dust, and we'll talk all about it. But this is an actual galaxy as well. This is also a spiral galaxy, kind of like what our galaxy looks like. But here's a little pro tip for you out there. There's another galaxy right here. Oh god, let's zoom in a little bit more. So there's the spiral galaxy in question. Really, really pretty. Blue stars along the edges. Reddish color indicating star-forming regions. We'll talk about that in a little bit. But look at that. There's a barred spiral galaxy in the distance right here. There's another spiral there. There's another spiral here. There's more galaxies in this photo. You just have to look a little bit harder. You can see some in the distance. Another one kind of off frame. Couple down here, and looks like they're getting cut off by the edge of the camera. That's why I like starting off with these, because there's always something kind of cool to talk about. But yeah, these are all stars in the galaxy that we live in. Things like this big blob back here, that's actually another galaxy in the distance. Some of these are going to be stars, just don't have a lot of brightness to them, so they're in the distance. So that is from the 2nd. Let's see what came next, because it's Monday, so we're going to go through some of the weekend stuff. Come on. Come on. April 3rd. Looking at Ingenuity. Now, we're going to talk about Ingenuity in a second. If you don't know what Ingenuity is, it's ingenious. It is a helicopter that rode on the belly of the Mars rover known as Perseverance. It's the one that landed just a few months ago. And it's just kind of been tucked away. About a week ago or so, they actually dropped the casing off of it. There was actually a little case on the belly of the rover, which we see here. They dropped the case off and then moved the rover away. And then they slowly lowered down Ingenuity and then drove the rover away. So it kind of dropped it down and scooted away from it, took a picture of it. The Ingenuity did actually survive the night on Mars. It does get very cold, and this thing's not exactly built for surviving on Mars for too long. This is going to be the first controlled flight of any sort of aircraft on a different planet. And it's basically a little drone. It's just a little helicopter. They're going to try to get it up into the air and then kind of fly it back and forth and see how they can control it via the rover. From all the way here on the planet Earth. But we'll look at this a little bit later. Oh, we can actually zoom in. Look at that. So there it is. There's the helicopter and its little carbon fiber legs. Picture of the rover belly. We're looking up the rover skirt. That's lewd. Lewd. Back to the archive. Ooh, that's pretty. So this is a picture of Saturn's rings on edge, and you have not one, not two, but 3 moons, satellites. Actually, I take it back. There are 4. Can you see the 4th one? This is the farthest it'll zoom in, but let's actually kind of cheat a little bit. So the rings of Saturn are right here. This is flat plane that we see there. And then we've got 1 moon here. We got a 2nd moon, obviously, in the back. We got a 3rd moon over here. Where's the 4th one? Do you see it? The 4th one's what we call a shepherd moon. It's that little dot right there. That's actually a moon in the ring system, and as these little moons go around through the ring system, their gravity causes little tiny waves, and it keeps the rings in line. Oh god, that's too big. Go back. Zoom back out. Too close. Okay, too far. So what do we got here? We got Titan. That's the one in the background. It's Saturn's largest moon. It's the only moon in the solar system with a atmosphere. Atmosphere made of methane. Let's see what else we got here. This is right here. This is Dione. What else do we got? I guess the little shepherd moon is Pan. I don't think it actually labeled what this one is. Does it? Oh, Pandora. That's that one out there. So, if you don't know what you're looking at, there's usually an explanation in the description right below it. Very, very cool. To be able to do this, so you can always, look up your friend's birthday or your mom's birthday or your dad or your cousin, whoever's birthday it is, and find him a picture from this little archive and send it to them. Hopefully it'll be a cool one. This is today's, called Wisps of an Exploded Star. It's actually looking at a chunk of the Veil Nebula. When stars get older, they puff up into what we call a red giant. Oh god, this is going to take a while, isn't it? Ooh. So it loses a little clarity when we zoom in, but that's okay, because this thing looks kind of cool. It's a huge image. That is the one thing you do have to be aware of. Sometimes when you click on pictures, when they come from astronomy archives, if they are the raw footage photo, they are going to be like a TIFF file, and they are going to be gigantic. They'll, I've downloaded like 300 or 400 megabyte files before that are just a single picture. So do be aware. Don't explode your phone or your internet connection. This is a chunk of the Veil Nebula, and that's just really, really pretty. Let's see, can we actually get let's get a full-size view, or is this the actual thing? Here we go. Wikipedia is not always the best place to get stuff from, but there are sometimes good starts. Okay, so there we go. This is the entire Veil Nebula. And that is just gorgeous. So a star at some point in the time in the past, times past, exploded violently, it looks like, and it left behind a huge trail of gas and dust, and it's been moving, being blown around through space. Now there's no, so to say, there's no atmosphere in space. Obviously, space is a vacuum, but the pressures from the stars themselves, they actually create their own pressure. We call solar winds, so to speak. There's also gravity that pulls the actual physical material around. You get these little waves floating around in space. And so what it looks like is we're looking at, looks like this chunk here. Where are we? Oh god, where did I lose it to? Okay, there we go. So that's the full, that's the entire Veil Nebula. And this is the chunk that they kind of zoomed in on, and you can just see all these beautiful waves. Now, each of these colors are going to be representative of a different element. If you look at the periodic table of elements, yes, I know we don't want to talk about chemistry because chemistry can be scary, but every element gives off a different color depending on how much energy it has. So a lot of the prevalent times when you see a picture of something in space, if it's got a red glow to it, that's likely the marker for excited hydrogen, likely the color called hydrogen alpha, which is the first level of excitement for the hydrogen atom, and it gives off a red glow. But the different elements give off different colors. You're going to probably put nitrogen as green, usually oxygen is labeled blue. All depends on how you want to make it pretty. But there is scientific reason, scientific basis behind these colors. All just depends on who's colorizing it. But yeah, this is really pretty, and you can actually see the motion of this object. This cloud is kind of tumbling through space. That's just awesome. So that's why we always start off with a astronomy picture of the day. Take a good 10-15 minutes, just talk about random things. If you have any questions, again, stop me as we're talking. And again, we kind of did see this a little bit already, but that's an actual picture of the rover far away from the Ingenuity chopper. That's a chopper all by itself, waiting for its first flight. You can always see some dust collecting on its surface of its rotors. Just a little box with some telemetry stuff and some carbon fiber legs. Super simple. Oh god. Looks like that's part of the heat shielding. Anyway, that's the Mars rover site. You can look it up. Just type in Perseverance rover, and you will get this website and be able to get all of its archives. And again, raw images are available to click around and look through and analyze for yourself. Become a citizen scientist. You don't always need a PhD to sit down and look at this stuff. Now, we're going to use that a little bit later. Let's swap over. Screen goes dark. Screen should come back up. And now we should see a giant eyeball. This is your eye. What you're looking at is the retina. Okay, no, I'm lying. This is our planetarium. This is a software package you can download yourself for free. I am not affiliated with them. I just like using their software. This is called Stellarium. There's little windows that are hiding over here that let you control things. You can put yourself anywhere you want on the planet Earth. Save that location. We are using Rio Rancho, New Mexico as our base because that is where our studio is. Beautiful land of enchantment. You can pick any date and time. So if you want to go back in time and see the day you were born, we can do that. We did that last time. The sky, the way the night, the way it was the day you were born. And we're going to use it to kind of find our way around the sky. Now, the sky doesn't change too much on a weekly basis. It does take a couple of weeks to kind of notice some movement, some change. And you'll always notice the sun will rise in the eastern part. You see an E over here to the left. The sun will rise in the east. We'll trek from the left to the right in our planetarium to the west. This, of course, was considered to be a deity by many various cultures around the planet, and that's why I love astronomy. Astronomy lets every culture on this planet kind of interpret what they saw. You know, Helios, or Apollo, the sun god in Greek, on a chariot, or the sun god Ra in Egyptian mythology, traveling from one side of the sky to the other. The sunset. Now you'll notice again the sky does change color. That is a change that happens because of our atmosphere. Our atmosphere does diffract off short wavelength light, which tends to be lighter blue in color that our eyes can see, and the longer wavelength light, so oranges and yellows and reds, not in that order. You want to think of the rainbow: Roy G. Biv, red, orange, yellow, green, blue, indigo, and violet. When you get more towards the violet side, those are shorter wavelengths, and the redder side is the longer wavelengths. And those, of course, sorry about that. That's my headset scraping the microphone pop filter. So, sunrise and sunset, we get a nice orangey yellow sky. Reddish colored sky, of course, depending on where you are. It turns out on the planet Mars, that is opposite. During the daytime, the sky has a red tinge to it, and during its evenings, during its morning and evening, sunrise and sunset, the sky actually diffracts off blue light. Very strange. Different world. Now, our planetarium is set up to look like an idealized sky, which means there's actually going to be more stars on the dome than I can actually see tonight, and likely you, depending on where you live. If you live in a big city, so we're talking big metro area, we're talking... Huh, that's cool. ISS flies over tonight, where I live. Nice. International Space Station flying over tonight. Good to know. I should have checked that earlier. So, what we're going to talk about real quick is light pollution. If you live in a very large metro area, that means there's a lot of city lights. And when there's a lot of city lights, there's not a lot of stars. It's going to look something more like this. Now, again, that's called light pollution. That is something that we ourselves do. That is caused by the city lights, lights of our cars, lights of the city streets. It disconnects us from the beauty of the Milky Way and the beauty of the universe itself, because at night, this is what you get to see, just a couple of little dots in the sky. So, of course, we've artificially changed that, and we've added some stars back in to what more likely was able to be seen long ago before, modern industrialization. And that's why, again, I find it really, really cool, because every culture looked at the sky, especially at night. Because at night, you see these various shapes. We call them constellations. There are 88 of them overall. These are what we call the fixed stars. These shapes are always going to be in these patterns. They don't move. The stars themselves are so far away that the patterns remain the same, regardless. So that means, if this is October sky, and then next October, it's going to look exactly the same stars in the same places. You see them always. And that's actually what is important about constellations. If you know which constellations are up during certain times of the year, you know whether it's time to plant, whether it's time to harvest, whether the rainy season's coming, whether a dry spell might be coming, just based on the way the climate works where you happen to live. Guess at 8:35 tonight, the ISS will be flying over, and that's what this dot is right here. So that'll be kind of cool. So if you are in the Albuquerque or in New Mexico, for that matter, maybe even Colorado, you should be able to see the space station flying over around around 8:35 tonight, give or take. So if you're wondering what the heck this big bright dot is, that is Crew Dragon. So that's docked with the space station. Yep, there's a space station. That's kind of cool. You can see it. Just go outside. You'll see a big bright white light as it travels from west to east from our point of view. Always really cool. Now, these constellations, they have various, attributes to them. Some of them are deities, some of them are animals, some of them are, gods. Which I guess is a deity, I already said that. Some of them are hybrids. Now, these constellations, believe it or not, some of them go back very, 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 very long time. This is Western astronomy, and I must point that out. Our planetarium, we start out using Western astronomy. Come on, get rid of that. There are various what we call star lores in the software, and you can actually click around. I always like clicking on the Chinese astronomy, just to show that it's the same exact sky, but they saw things very differently. They have different names to them. The Western astronomy stuff usually has Greek and Roman, which is also built on Egyptian, which itself is likely built on Sumerian and Babylonian. So these go back literally to the beginning of civilization. There is what is called the Dendera calendar, or the Dendera star chart. It's actually a circular chart that was found in Dendera. It's in Egypt. Sadly, it was exploded out, and they used saws and gunpowder, and they blew this thing out of the wall. It's actually on the roof of a small fixture of a temple, the Temple of Hathor in Egypt, and they yanked this thing out, and this is like during the 1800s. They yanked this star chart off the roof, packaged it, took it to France, and King Henry VIII, I guess, 18th, 8th, put it in the royal palace and whatever, and now it sits in the Louvre. And so if you actually go to Dendera, go to the Temple of Hathor in Dendera in Egypt, you get to see a copy of it. The actual original is in France, and I think that's a damn shame. But the reason I'm telling that story is that the sky chart has what we would call the constellation Orion, and a lot of these shapes are on it. What we would call Hydra the Snake, Crater the Cup, all these things, they're on there. What we call the Big and Little Dipper, Big Dipper's not a constellation, it's an asterism. They were jackals on this particular star chart. So these things go back to ancient Egypt. We're talking pyramid times, or further back, what is called the dynastic times of Egypt. In fact, what we call constellation Orion supposedly was referred to as the constellation, or the body, of Osiris, the god of the dead. Orion, of course, here in Greek or Roman, is usually holding a club and a pelt of a lion. The club, an indestructible thing, and he was on a quest to kill all the animals that he could, just to say that he killed one of everything. Other stories have him holding a sword and a shield. Same. Well, howdy, how are you doing? Good to see ya. Nice to see ya. To see ya nice. Welcome to our dome. It's been a while. I hope you are doing well. For those of you that can't, I don't have chat up, so that's why people don't see what I'm talking about. But whenever I see chat, I always try to acknowledge you. So again, post and chat whichever broadcast you are watching. Where were we? Oh yeah, Osiris. So behind Osiris was his wife, Isis, and Isis actually is related to Sirius in these mythologies. So this whole area, a lot of Egyptian mythology around it. Let's actually talk about this now. I've been talking about Orion and Sirius and Procyon for a couple of months now because they're the easiest things to see in the evening sky throughout the winter. Now we are tailing out of the winter, we are heading into spring, and you'll notice that these stars are no longer on the east side of south. So if you break the sky up into a grid, right? Let's put north up there. Anytime you have stuff that's kind of rising in the east, it's going to last longer. If it rises right in the east at sunset, it'll last the whole night. And that's the way it was with the winter constellations during November and December. Orion was right along the horizon in the east. As we've gone from December to January, January to February, February to March, you'll notice Orion has processed through the sky. And now, right at sunset, Orion is actually low in the southwest sky, which means it will be exiting our field of view. As we orbit around our sun, these constellations will go away and become obscured by the brightness of the sun, only to be replaced with different constellations, the springtime and summertime constellations. And that's actually related to one of the stories of Orion. One of the stories, again, I said he was trying to kill all the critters of the planet. Well, he pissed off some of the deities in Greek or Roman, and they sent a scorpion, and the scorpion stabbed him in the foot, killed him. That scorpion is represented by the constellation Scorpius, or Scorpio, and that's a summertime constellation. So you'll notice Orion and the scorpion are never in the sky at the same time. They're chasing each other. Orion is the 3 stars in the belt region right along here. Let's zoom in a wee bit. Betelgeuse, his shoulder star. Bellatrix, his other shoulder star. Rigel, his knee. And Saiph is the other knee. Each star in the belt does have a name. Alnitak, Alninam, and Mintaka. Those are Arab names. Very, very cool. Lots of Arab astronomy. In our modern astronomy, people just don't pay attention to it. A lot of the star names come from Arabic. Let's use astronomy. Let's use Orion to do some visual astronomy. Again, you want to just go out, try to identify these stars. If you can find these 7 stars that we pointed out, there's 2 shoulder stars, 2 knee stars, that's 2 and 2 is 4, plus 3. The belt stars, that's a total of 7. If you can find these 7 stars, you're going to find 6 or 7 more constellations. Let's start by finding an obscure one. Draw a line straight down from Betelgeuse through the left belt star, and you end up down here. Why? Because there's a bunny rabbit down here. There is a oddly shaped constellation called Lepus the Hare. You got little bunny ears. Again, it's really hard to see if you're in a city that's heavily light polluted, but you might be able to see this little rhombus, the square, the body of the bunny, depending on where you are. Drawing a line through the belt stars towards the eastern horizon, this way, brings you to Sirius. Seriously, it's really bright. I know, buddy. My dog is named Sirius, and he just looks up every time I mention his name because, well, that's his star. So, he's not going to like this next segment. Sirius, also again known as Isis in Egyptian. This is the brightest star in Canis Major, the big dog, the hunting dog of Orion, hypothetically. Located in the chest or in the throat area of this big puppy in the sky. Draw a line from Sirius back to Betelgeuse. Complete a triangle. This is Procyon up here. This completes your winter triangle. Again, it's getting lower and lower, which means winter is going away. Procyon is in Canis Minor, the little dog, also known as a hot dog, also known as a dachshund, if you ask me, because there's 2 stars making up this constellation. And as you can see, there's actually Monoceros, the unicorn, between the 2. But in all honesty, unless you're out in the middle of nowhere, you're not going to see very many stars. It's very, very dim. That's a very old constellation that requires really good sky to see, but the rest of these you can see pretty well, even from a big city. That's why we start out with them. Now we're going to go to the right of Orion. We're going to go towards the west. Draw a line through the belt stars and draw a line this direction towards the west. You will see 2 patches of stars. Now, these are actually open star clusters. Let's draw that line one more time. There we go. These 2 open star clusters are visible throughout the winter months, and they are going to be the first things to leave our winter sky as it goes into spring. The V of stars is the face of Taurus, the bull. They are known as the Hyades. It actually does look like a V of stars. The bright red eyeball is called Aldebaran. It's the eye of the bull. Oh, by the way, I think I forgot to mention, when I said Beetlejuice, apparently that translates out to armpit of the giant. How about being named Armpit? That kind of sucks, huh? But it's, you know, in his armpit. And you've probably heard some of these if you were one of those Harry Potter nerds. You've heard the name Bellatrix, you've heard the name Sirius. These are where they come from. Very, very cool. Aldebaran, the eye of the bull. And again, the Hyades, the V-shaped face. The Pleiades are the open star cluster right back here. They are the seven sisters. You really can only see six. There is a story behind why the seventh one turned out her light. I clicked on Alcyone because I'm a badass that way. Alcyone is actually the name of a car that I have out in the driveway. It's a SVX Alcyone, as well as the name of our cat. So, yeah, we have 2 stars as pets. This is an open star cluster. You notice that the stars are lighter blue in color. Open star clusters tend to be younger and bluer, and we'll talk about star colors and what that means for their ages and things like that in just a little bit. Bear with me. Remember when we looked at that first picture with the spiral galaxy, all the blue stars were out along the edges? Well, it's true. As we orbit around our sun, we look at different parts of what we call the Milky Way galaxy. During the winter months, we look towards the edge of the Milky Way. You see the Milky Way in our planetarium dome here. Let's see here. Can we get rid of the atmosphere? Yeah, it's this little cloud you see in the background. But during the summer months, we look towards the heart of the galaxy, and we'll talk about that in just a little bit. Let's get back to finding constellations, shall we? So we found 1, 2, 3, 4. Let's find 2 more. Let's go back to Orion, go from his knee star, Rigel, up through Betelgeuse, and keep going. I need to move the dome because I'm a bad, bad person. There we go. You'll notice there's 2 stars parallel to each other up here. They're about the same brightness. One is named Castor, the one on the right is named Castor, the one on the left is Pollux. These are the Gemini twins. Wait a second, we're talking about zodiac constellations, aren't we? The zodiac, there are 12 months of the year, there are 12 zodiac constellations. That is not a coincidence. There is a reason for that. Astrology and astronomy are 2 different things now, but long ago, when we're talking about the cradle of civilization and kind of the beginnings of humanity as we know it today, they were one and the same, and they used divination and, you know, where the stars were to kind of talk about how things were going to go in battles and things like that. We don't really do that today. Some people do, some people don't. But we're talking about pure astronomy here, and that does include talking about zodiac constellations. We'll talk about what the zodiac is. It's actually this line right here in just a second. Let's find 1 more constellation and then a planet, and then we'll start talking about other things, shall we? Oh, look at that. We got some spam in chat. Looky that. Spam, 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 spammity spam. Draw a line from Scythe through Betelgeuse and keep going. Actually, between Betelgeuse and Bellatrix, you will find a bright yellow star named Capella. Capella is in Auriga, the charioteer. It's actually supposed to be the bright eyeball of a goat that the Auriga charioteer guy is holding on to. Again, this is the winter sky that we'll be exiting very, very soon. As we rotate our head, we rotate our dome slightly, we're going to look more towards the east. Right at sunset, we're going to notice a backwards question mark in the sky. You guys see that? Backwards question mark. Kind of goes this way. Looks a little bit easier this way. Looks almost like a sphinx, doesn't it? Again, this goes back to ancient times, going back to ancient Egyptian. If you didn't get a chance to see, I did share a link to it. That was a really cool thing that happened in Cairo this weekend. They are opening up a brand new museum, and they moved 20... Was it 22? Yeah, it was 22 mummies of various pharaohs from the museum they were held in before to the museum they will be housed in now, which I believe is the Grand Egyptian Museum. And they did a big procession. It was really, really cool. And again, they all believed that they would be, their spirits would be shot up into the stars and they would continue to live forever. I guess as long as someone is remembered, they still live on, right? So I guess they got their wish. The bright star at the bottom of this question mark is Regulus. It is a bright blue star. Again, blue star. What does that mean? Star colors. We're going to talk about that in a second. I promise. This weird slug-looking constellation that comes up, that is also a zodiac constellation. That is my zodiac constellation. That is Virgo. So what is the zodiac? Let's just get to that now, shall we? The zodiac is the path of the sun through the sky. Happens to travel through 12, it's actually technically 13, but 12 constellations, right? Not only the sun, but the moon and all the planets travel along that. And as we zoom in over here, remember we have Taurus the bull. If you've been paying attention to our shows and, looking at our sky updates every month, the planet Mars has been kind of floating its way along through Taurus. Just a few weeks ago, it was right below the Pleiades. You could see Mars just kind of sitting here, and it's drifting up this way. To find Mars right now, you just draw a line through Scythe, the knee of Orion, and through his shoulder, Bellatrix, and you'll see Mars is just kind of sitting there. So right above Aldebaran. In fact, you could make a triangle between Aldebaran, Mars, and Betelgeuse for the next few weeks. Mars is going to keep kind of going in this direction. So it'll be changing slightly every night. But let's go back to Zodiac. So it's the sun and the moon and the planets all traveling along this. Now, the planets themselves... Let's go back a little bit. Let's talk about language and cultures. The Greeks is the culture we'll be talking about here. They called all these objects you see above us asterisks, which means stars. That's where the word asterix, that's why it's a star on your keyboard. Asteris means stars. And then they had these other stars that they called asteris planetis, which meant wanderer or vagabond. These were bright objects that were in the sky and they were moving around. Of course, back then there were no satellites like we have today or the space station. The only object they could see that weren't part of these constellations, as we call them, were the planets, and they were the sun, the moon, what we today call Mercury, Venus, Mars, Jupiter, and Saturn. That's a total of 7 objects. How many days of the week are there? There's 7 objects. So the calendar that we use today is a modified version of an old ancient calendar, using 7 days representing each of these 7 objects. So sun, Sunday, moon, Monday. Tuesday is Mars, Wednesday is Mercury, Thursday is Jupiter, Friday is Venus, Saturday is Saturn, Saturday. The word month comes from moon. It's the cycle of the moon, going from new moon back to new moon. And every month, there's 12 of them, so that's how you build your calendar. There's 12 constellations, 12 months, 7 objects. Now, of course, we don't call the sun a planet today. The sun is a star, but we call them the 7 classical planets, so the sun and the moon included in that. The sun, of course, a star, the moon, our satellite, the moon, orbiting around us. Let's rotate around. We'll take a look at more of these zodiac constellations. We're going to get rid of the atmosphere because the sun will come up, but I want to be able to show all of them as we go along. Virgo, you got Libra the scales. Again, Scorpius or Scorpio. Sagittarius. What's your sign, baby? This is what they're talking about. Capricorn. My wife and some very close friends are Aquarius, the water bearer. Aquarius was on that Dendera sky chart as well as Pisces, the fish, Aries, the ram, and then back to Taurus, the bull. And you'll see there's the sun. And so the sun will actually drift as we orbit around it. From our point of view, the sun appears to drift from constellation to constellation. And so if you can kind of build an entire year of constellations, if the sun is here, obviously a certain other set of constellations are going to be up at night. That's how you know what season you're in. That's how you know when to plant and when not to plant. Very, very cool. All goes back to just paying attention to the sky. Go figure. Let's reset it to tonight. Unfortunately, the only planet out tonight is Mars. If you want to see the rest of the planets that you can see without a telescope, you have got to be up in the early morning. In fact, let's zoom forward a little bit. And by early morning, I mean you have to be up at around 4:30 or 5 o'clock in the morning. At that time, if you look towards the east... Come on, let's get rid of all this junk. Come on. One more. There we go. If you look towards the east, you will see this. You will see the planet Jupiter and the planet Saturn rising up just before the sun rises, and as well as the moon. The moon is our only natural satellite orbiting around our planet Earth. It'll be a waning moon, so it'll look kind of like this for the next few mornings. Bright side on the left side. Whenever the right side is bright, we call it a waxing moon. When the bright side's on the left side, we call it a waning moon. We'll look at the moon in just a second. Let's look at Saturn. There's Saturn. Beautiful ring system. We kind of looked a little bit at the rings a little bit earlier. It's my personal favorite planet. Beautiful rings out. Saturn is not the only planet with rings. It's just the only planet whose rings we can see. Jupiter, Saturn, Uranus, and Neptune, the outer planets, the gas giants, they all have rings. We just don't get to see them if they don't have a lot of ice on them. This is Jupiter, and it's for what we call the Galilean moons, named for Galileo Galilei, who first discovered them in 1610 with a very what we would consider a rudimentary telescope today. It was revolutionary at the time. It's kind of a modified version of a telescope that a man that's been kind of lost to history named Hans Lippershey, or let's try that again. Boop. Oh wait, we're alive. Hans Lippershey. He designed this thing. He called it the Looker. It was a telescope. Kind of looks like a little viewfinder. A spyglass is what we would probably call it today. You got Io. It's actually the innermost of these four, so you can't really tell how far away they are until they're all on one side of Jupiter, but Io is the closest, then Europa, and then Ganymede over here, and then Callisto. This is the largest moon in the entire solar system. In fact, if this moon, Ganymede, weren't orbiting around Jupiter, we would consider it a planet. It is huge. It's actually about the size of Mercury. There's Jupiter up close. We see the giant spot known as the Great Red Spot in its upper atmosphere. We'll look at Jupiter in just a second, but I just wanted to show you where the planets were. Here comes that weird thing in the song. Don't know why the song does that, but that's what it does. So that's where the planets are, and you see where the moon is. Let's actually talk about these. Again, if you have any questions, feel free to stop me as we go along. I'm just going to try to walk us through things. Try to answer your questions literally as we go along. Let's look at the moon first. So we're going to look at this simulator. Let's zoom in slightly. This is the Earth. We're looking at the North Pole. There we are, a stick figure. There's the moon, and then the sun is not in the image here, but it's to the left, giving off a bunch of sunlight. As the moon orbits around the planet Earth, the brightness begins to show up on the right-hand side. That is sunlight being reflected back towards us. There is an angle between the sun and the moon and us as the observers, and that angle is slowly filling up, as you can see. When the moon is 1/4 of the way around the planet Earth, we call it a quarter moon, a first quarter moon, and the bright side will be exactly on half of the image side we can see. The moon is what's called tidally locked. This is the only face you will ever see if you stay on the planet Earth. After you go from a waxing crescent, you go to a waxing gibbous. It's not full, it's not a crescent, it's kind of an in-betweener. It's the middle child syndrome. When the moon rises at the same time the sun sets, they are opposite each other in the sky. We call it a full moon. We see the entire side that we can actually see from the planet Earth. Looks something like that. Each full moon does have a different name. I believe the moon this month is called the pink moon. It actually will not physically be pink. It's just the name of some of the named after some of the flowers you start to see that show up. Some moss that gives off a pink color to it. There's a wolf moon. There's a strawberry moon. There's a ice moon, or I'm sorry, a snow moon they call it. Third quarter moon. Here we are. We're 3/4 of the way around the planet Earth. We will come back to what we call new moon phase. Now, during new moon phase, that is when the moon's reflecting all the light back towards the sun. The bright side's on the back side, the far side. Sorry, Pink Floyd fans, what people call the dark side of the moon. Yeah, it gets all the sunlight during new moon phase. But, hey, it's still a great album, right? There we go. That's a full entire, what we call a month, as we orbit around the planet Earth. So, let's get over here and look at Universe Sandbox. You can buy this software off of Steam if you'd like. This is nothing special to me. It's not like I created it or anything. I just happened to buy it. Here we are looking at the Earth. As we talked about earlier, there is light pollution. You can see the city lights of many, many large cities. There's Cairo and the Nile River. There's the New York and the Eastern Seaboard. There's Texas. Lots of bright cities down there. If you live in the Southern Hemisphere, here's a look at Australia. Good dark sky in the middle of nowhere in the outback. Got India. Oh, goodness, we have a raid party showing up. Culprit, good to see ya. Nice to see ya nice. Welcome, everybody. Nightbot is being a jerk already. Look at that. Zarkosis, welcome, welcome. We are talking about the moon at the moment. I really gotta turn Nightbot off. I don't know why it's doing this. I need to set Nightbot up. It is raid time. Welcome, welcome, everybody. You caught us talking about the moon, which right now is in waning phase, so you will see this in the early morning. But here we are looking at our satellite, the moon. Yeah, I know this game. You might know this game. I believe I actually learned about this game. Thank you for the follow, friend. Figwasakin. Welcome. I learned about this from a friend of mine who was like, hey, you should check out Markiplier. He's playing this game. It's in space, and he's blowing up stuff. So I looked it up, and yeah, it's actually pretty cool. You can use it for not just blowing up stuff. You can use it for astronomy, so that's what we're using it for. Here we are looking at the moon. If you've ever gone outside and looked at the moon, you'll notice you only see one side of it. That is again, a thing called tidally lock. The moon always keeps that same face towards us. There is a backside to the moon. You found this game in a YouTube video. Yeah, some people play it, and they do a lot of fun things. You see these dark areas? We call these the mare, the seas of the moon. Now, they're not actually seas, and if you're a Futurama fan, you know the song, "We're whalers on the moon. We carry a harpoon." No, there is no water on the moon per se. There's actually ice water frozen in some of these craters and just under the surface. But these, what we call mare, these are just seas of lava that eventually solidified. This is the backside of the moon. This is the side of the moon you've likely never seen unless you've looked at it in a book, or if you were lucky enough to fly around the moon in a space capsule. Talking about the Apollo missions to the moon during the 60s and 70s. All of these craters have names. I am not going to name them because I do not know them all. You can find them in various moon charts on NASA's website or in multiple books. But this is the backside of the moon. This right here is what's called new moon phase. This is what we see from the Earth. Nothing. But the backside, the dark side of the moon, gets all the sunlight. That's the Earth in the distance, as you can see there, rotating around. And yeah, this is how the phases work, but in three-dimensional space. If we were actually connected to the moon instead of to the Earth. Very, very cool. Now, if you are new to the chat, obviously, welcome, number one. If you're new to the channel, please like, subscribe. We have multiple channels. We're actually broadcasting right now on Facebook and Twitch and on YouTube. All at the same time. So, how long have I had this game? I've had this for about 1.5 years, and I use it mostly to kind of explain science-y stuff. So we'll be talking about the planets now. We did talk about where the planets were before you guys got here. I apologize. We'll look at them when we get back, but this is our solar system, okay? We're going to look at the solar system, the way it's set up, and talk a little bit about it. Ask questions whenever you want throughout this whole thing. This is the sun. This is the bright star. Well, it's bright to us because we're close to it. We'll look at stars in a little bit, and you'll notice that the sun itself is not all that bright and not all that big compared to other stars. On its surface, there's actually convection happening, and convection is stuff bubbling up to the surface and then cooling off and then returning back down. The sun is made of plasma. It's gases heated up and excited. It gives off sunlight. Takes about 8.4 minutes for sunlight to get from the sun to us. Now, let's look at the structure of our solar system. Some of you may know this, some of you may not. You might find this concerning. Don't be. This is a beautiful thing to learn about. Our solar system is set up kind of like a flat plane. Imagine making a pizza. When you make pizza, you make a little ball of dough, right? And then you see someone starts, or you yourself start spinning it, and what does it do? It flattens out. Over time, the cloud that made our solar system, our sun, it started to kind of squish down. You'll notice all the planets appear to be on a flat plane. That plane is what we call the plane of the ecliptic. It is the zodiac constellations. That is why, from our point of view, going back to our other software, that is why we see the sun, the moon, and all the planets travel on this little archway in the sky. Yeah, say hi to each other, make friends. Be friends, be one with the universe. Back to Universe Sandbox. The inner planets we call the terrestrial, Terra, Earth-like planets. We start off with sun-scorched Mercury. Name for the messenger god of Roman mythology, Hermes in Greek. No atmosphere on this planet. Small rocky world very close to the sun, burning hot, so to speak, but not burning the way you would think. There's no atmosphere, there's no convection of heat. If you stand right along the edge between light and darkness, your left side, let's say, is in the sun, well, it's scorching, 500-600 degrees. If you're on the other side, your right arm's in the darkness, well, it's freezing. There is no choice. You don't understand, well, you know what, if you don't understand astronomy stuff, you're in the right place. Because we're going to be teaching you some basic things. We got a bunch of videos on our YouTube page, so just look for YouTube. Earthshine Education on YouTube. There is a link, I believe, on the Twitch page to it. There's also a Facebook group or a Facebook page, Earthshine Education as well. They all kind of link towards each other. There's even a Twitter page and an Instagram page as well. Here we are looking at Earth's evil twin. This is the next planet of the solar system. This is Venus. Some people call it the morning star. Some people call it the evening star because you can only see it in the morning or in the evening, right before the sun rises or right after the sun sets. It has a very bright appearance in the sky because of this very thick atmosphere that we see here. It is about the size of the planet Earth, but that's where the comparison ends. I mean, I know where planets are, and that's about it. Well, you know what? We're going to teach you a little bit about everything. We got a bunch of videos that we're putting up that are pre-made. So I have a video that I made about how telescopes work. I put that up on our YouTube page. I'm actually finishing editing a video, the beginning of our Astronomy 101 series. I'm going to do an entire Astronomy 101 class on YouTube, video by video. So it's as if you went to college and took an Astronomy 101 course. I'm going to be your professor. I'm putting it together. I've got 5 videos kind of already, written out, scripted out. I just need to kind of start stitching them all together and putting them as whole videos. So please give me some time to finish that up. We'll get video called episode 0 up probably by the end of this week, and then I'm hoping to get episode 1 by the end of next week up, and then episode 1.1 and 1.2, which are supplementary, those will be by the end of April, early May. So with Venus rotates the wrong way. We don't know why. The sun rises in the east and sets in the west. You are streaming on YouTube. Yep, I am multi-streaming on all 3, YouTube, Facebook, and Twitch, all at the same time. So you can pick whichever one you want to watch on and go from there. Or you can share it to your friends, because some people don't have Twitch, so they can always find me one way or another. The sun on Venus rises in the west and sets in the east. Nobody knows why. That's opposite the Earth. Also rotates very, very slowly. A day on Venus is almost as long as the year on Venus, which is, 248 days. So very, very different. We already looked at the Earth, but since some of you just got here, there we are. There's our planet Earth. Beautiful little planet. Let's slow it down a little bit, and you can pick out your own city. The Earth at night, it is kind of pretty to see, but this is what we call light pollution. This is bad. It means you don't get to see the sky the way you should. We did look at where to find the planet Mars. This is the 4th planet of our solar system. It is visible tonight if you go outside and look just above Orion, the constellation. This is Mars. This is the planet that we seem to have the most interest in for a place that we could maybe one day live. It is about half the size of the Earth, but weirdly it has a day that's not much longer than ours. It's a 24-hour and 37-minute long day on Mars. We call it a sol. And so it's a little bit longer. So if you were to kind of keep track with Earth and live on Mars, slowly over time, your day would be a couple of minutes off, By the end of a week, you're a few hours off of an Earth day. On Mars, we have what are called the Tharsis Montes, which are these shield volcanoes. They look like pimples right here. And then there's Olympus Mons. I cannot explain how huge it is without you looking at a map. Imagine looking at the United States. This right here, this volcano, would fill up an entire state. The state of New Mexico, the state of Arizona, the state of Utah, or the state of Colorado. You pick one, that volcano is going to fill up the whole thing. We're talking 800 kilometers wide. It's about 400 miles wide for those of you that don't use metric. That thing is huge. Also huge is this huge crack. It's like the Grand Canyon, but grander. It's 8 kilometers deep at the deepest point. It's 5 miles deep. And from one side, if you were to put San Francisco over here, New York City would be somewhere on the edge over here. So this thing would cross the entire United States. Huge, huge canyon on Mars. Very, very interesting. Once you pass Mars, you enter into what's called the asteroid belt. Now, asteroids come in different shapes and sizes. Some asteroids are literally just little balls of rock. Some of them are huge boulders. Some of them are actually chunks of iron. And they look like this, so they're like little planetoids. Other asteroids, I'm trying to find one that's oddly shaped. Some of them are going to look like a football or like a potato. Potato, patata. Nope. That's another round one. Nonetheless, asteroid belt is interesting to me. There's a lot of rare earth minerals, as we call them. So you get like iron and gold and tin, lithium. Not a lot of lithium, but it's out there. You could hypothetically form a mining company and go mine an asteroid. Once you pass the asteroid belt, we're going to reload the solar system just to get these rings back. Once you pass the asteroid belt, you enter into the realm of the gas giants, starting with the biggest planet of our solar system. This is Jupiter, which, as you can see, rotates really, really fast. There you see the Great Red Spot. That is the huge hurricane-like storm. You could fit the Earth into it a couple of times. This thing's bigger than our whole planet. Just that one storm. When you see a hurricane on an Earth map, Earth weather map, just think that's nothing compared to this. This is Jupiter. It's the biggest planet in our solar system. Its gravity actually makes the sun wobble. It's that big. It's really big compared to the size of the sun. Saturn, we're not going to look too much at here because for some reason this software doesn't have rings on Saturn, and it makes me very, very angry. Again, as we saw earlier, Saturn does have beautiful rings. And, well, here, for those of you that weren't here, let's look at Saturn. If you don't know what Saturn looks like, or haven't seen Saturn in a while, it looks something like this. There we go. Saturn does have beautiful rings, and it also does have cloud structures. You are not seeing the surface of the planet, but you are seeing an atmosphere. Very, very thick atmosphere. You see cloud structures. There's actually a weird shape at the top of the planet. Kind of looks like a 7-sided shape. We're not really sure how that's formed, but there are strange shapes that do form due to fractal movements. We're going to talk about fractals one day. I'm hoping to get Dr. Jonathan Wolf to do a little interview with me, and we'll do a podcast, and we'll talk about fractals in nature, fractals in math, what a fractal is, and how it kind of affects you. If you must know what a fractal is, just go look it up real fast. It'll blow your mind. Here we have Uranus, the next planet out. It is on its side, so if you imagine a water bottle next to you, north is up, south is down, tip it over, put it on its belly. That's what happened to this planet. Why? We have no idea. The ring system is also on its side. All the moons are on their side. The entire planet, the entire system, tipped over. We have no idea why. One of the other mysteries of our solar system. Neptune, the final gas giant known for its bright blue color, as you can see here, named for Poseidon or Neptune, the god of the sea, Greek or Roman mythology. Lots of cloud activity on Neptune that probably shouldn't be there, so we're pretty sure that there's some sort of activity happening under its atmosphere. So either the planet itself is shrinking, or there's some sort of nuclear energy happening under it. We're not really sure, some sort of decay happening. As we go out further, my rings are gone again, come on. As we go out further, you start to see the realm of the comets that's out here. Comets are balls of ice, gas, and dust, frozen way out here in what's called the Kuiper Belt, and then even further out into what's called the Oort cloud. Here we are in deep space. You see the sun is just this little tiny yellow dot now. And as we keep zooming out, you'll see the sun basically disappears from our point of view. The sun is but one star among this huge cloud that you see in the background. And that cloud is called the Milky Way Galaxy. We talked a little bit about galaxies at the beginning of the show, but we're going to talk about that again. Let's talk about stars, because before the show, I actually got a message from somebody, and they asked me to talk about stars and why their colors were different. In particular, he was talking about a red giant star, because that particular star that he had sent me an article on, it took up all the space from the sun out to the orbit of the planet Saturn, so out here. It took up all of this, just one star. How? How is that possible? Well, it is a thing that does happen. And just to show you, it's not the same star, but I'm going to use this star. You can see this is one star, and it takes up everything all the way out to the orbit of Jupiter. Just this one star. Why? How? Well, let's talk about it. To do that, we're going to get rid of everything. Goodbye, everything. We're just going to have this. We're just going to be floating in space. And we're going to talk about science. We're going to talk about this. This is called the Hertzsprung-Russell diagram. When you look at the sky, stars are going to have different colors. This is actually a chart that shows you a lot of information in a very compact way. On the bottom, you have surface temperature. Stars that are blue, so this side, are considered very, very, very hot. Stars that are red, so on this side over here, are considered very, very, very cold. Our sun is a yellow star, so it's kind of in the middle. The sun is located right here. You can see it labeled sun, but if you can see my mouse moving around, you see the sun is right here. Our sun is our measuring stick. It is our yardstick. It is our, standard. The sun is an average star. Stars that are redder in color tend to be colder and smaller. Luminosity, brightness, is this vertical over here on the left, which also has something to do with how big they physically are. Smaller, redder stars are down here. Hotter, bigger, bluer stars are up here in the top left. Hot like fire. But you'll notice there's a couple of other regions, aren't there? There's a region called white dwarf down here. They are hot, but they are small. They're actually the core left over after a star has died. You'll notice in the top right you have giants and then supergiants. These are stars that are physically getting bigger. Stars are not always the same size their entire life. A star is a nuclear furnace, and in its core, it starts out fusing the element hydrogen into the element called helium. And when two hydrogen atoms love each other very much, they merge together, and they release a little bit of energy. And that energy hits other hydrogen atoms, and that forces other hydrogen atoms to merge together, and they release a little bit of energy. And that starts a chain reaction. That is the core, the nuclear fusion inside of a star. But eventually it runs out of fuel. The gas tank runs empty, and you run out of hydrogen. The outer layers start to cool off because the star isn't producing all that much energy anymore. To try to stay alive, the star will first start to shrink, and then it'll start to expand on the outer portions. Stars, much like ogres, like Shrek, are like onions. There's different layers to them. The inner layers start to shrink and compress to try to increase pressure. The outer layers start to puff up, but they're also cooling off. And what do we say about cooler? They turn redder. Doesn't the sun get a bit bigger with some time too? Yes, the sun will go through this exact process that we're talking about. The sun will eventually go from being a yellow dwarf star into what's called a giant star. Some stars will kind of go up here, they'll turn into a giant, and then they'll die. They'll quietly die, and they'll turn into a white dwarf. So they'll go from up here to down here. Some stars will go up, become a giant, and then go back towards the main sequence as they start fusing helium into other elements, and then they'll puff up again, become a giant, and then they'll try to fuse carbon and nitrogen and oxygen, and then they'll try to fuse other things. They'll keep going back and forth. Some of them will just keep getting bigger and bigger and bigger. That's how you get these supergiant stars. And then eventually, these things, they don't die quietly and turn into white dwarfs. Oh, no, 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 no. These things explode violently in what we call a supernova. They explode in mere instant. Like, we're not even talking in a second. This entire star just implodes on itself in milliseconds. And then it explodes violently and leaves behind a huge cloud. Actually, a cloud kind of like this that we talked about at the beginning as the Veil Nebula. So this is what's considered a supernova remnant. Come on. Something like this. Just a huge explosion, and material floats out into space. But this is also beautiful, because you get heavy elements. Look at a periodic table. You get iron, you get plutonium, you get uranium, selenium. All these heavier elements begin to float around into space, and that over time starts to float. How much area? It depends on the star. And it also depends on when we see them. For example, let's go back to this. Well, we don't want to look at Saturn. Saturn's not a supernova. Let's reset the sky real fast. Hold on 1 second. I'm going to reset the sky. There was an explosion in the year 1054 AD. We're in 2021 now, right? But back in 1054 AD, somebody noticed a star. It appeared in the sky, a little white dot in the sky. And it stayed there for a while. You could see it at night. You could see it in the day. No one was really sure what the heck it was. And then it disappeared. Years and years and years later, people put two and two together, and they realized that what was seen long ago was the death of a star. And today, we call it the Crab Nebula. It's actually out tonight, and it looks something like this. Over the last, 600 years or so? 1054, so, sorry, it's been 1,000 years, give or take. A little bit. This is as big as it's gotten. Used to be a little tiny cloud, and it's gotten huge. You see how violent that is? You see all these little strings kind of traveling through it? That's material from the star being blown apart and spread out into space. There's a huge amount of magnetic radiation happening in the middle here. You don't want to get close to one of these, because as a human, you will just get irradiated. There's X-rays and gamma rays floating out from this. If you've ever been to a hospital and had them do an image of your body, do an X-ray, they can see right through you. That can actually kill you if it's really, really energetic. It's very, very different. A star like our sun will not explode violently. A star like our sun will die quietly and leave behind something like this. Come on, I gotta get it up in the sky. There we go. When a star like our sun dies, it leaves behind something more like this. Just a little kind of puff out into space. The star just kind of gets bigger and bigger and bigger, and then it kind of lets the outer layers go. That little dot in the middle, that's the white dwarf. It is a hot core left over. About the size of the Earth, Very, very hot. But usually made of carbon. So it's literally a glowing diamond in the sky. These outer layers are going to be hydrogen, and then helium, and then lithium, and then oxygen. These are things that we know today. You look around, you see them everywhere on our planet. You breathe them in. What you must remember is that you are made of the dust of stars. Your iron in your blood, that's stardust. The surface of our planet, stardust. Let's go back to our planetarium back here. Come on, let's go back to the other one. There we go. Let's look at stars as individuals. Just like you and I are very different, we're different sized, well, stars are also very different. We now know a little bit about their colors showing their temperatures and how big they may be. So there's the sun. We're going to start off by looking at our friend the sun, and we're going to pause it so nothing's moving. Let's put in some other stars and start comparing them, shall we? Let's look at a red dwarf star. Let's look at Wolf 359. If you are a Star Trek fan, you have heard of Wolf 359. Look at how small that star is. This is a red dwarf. And you can see it is kind of reddish orange in color, but look at how big our sun is by comparison. If you had a planet around this star, those planets would have to be a little bit closer to the star to have the same amount of heat that we get from our sun. Let's look at some of the stars that we were talking about earlier when we did the planetarium. We talked about Sirius, the dog star. Sirius is a bright blue star. It's not much bigger than the sun, but it is a little bit bigger. And you see, inherently, it is much brighter. It is a blue color. So blue stars, hot. Yellow stars, average, kind of in between. Red stars, cold. Now, it's not cold for one of us humans, but for a star, a red star is very cold. About 3,000 or 4,000 degrees Celsius, or about 8,000 or 9,000 degrees Fahrenheit on the surface. The sun's about 10,000 degrees Fahrenheit. It's about 5,800 degrees Celsius on its surface. Sirius is going to be around 9,000 degrees Celsius on its surface. Very, very hot. Let's look at other stars, shall we? We talked about a star named Betelgeuse, the armpit of Orion. Well, let's take a look at Betelgeuse. Wait a minute. There's Sirius. There's the sun. There's Wolf 359. That is Betelgeuse. Remember when I said stars will puff up? Our sun, at some point, will puff up eventually and maybe not get this big, because this is a supergiant star. But it'll get pretty big, as you can see here. Stars can get absurdly big. This isn't the only supergiant out there. This is Betelgeuse, Antares. Where are you? There's Antares. As you can see, Antares is about the same size. Maybe just a smidge smaller. And again, the sun is still here. The sun's way down here. Just to show you the difference in star sizes. So these stars can all be kind of floating around in space. Some of them, when they're small stars like Wolf 359, they'll have companion stars. So you'll have two stars kind of floating around together. Let's look at Spica. Spica's a small little blue star. What other stars can we put up here? There's Altair. There's Procyon. Procyon's another star we talked about earlier. Procyon's about the size of our sun, give or take. We're just looking again at how stars differ in size. Look at how big these stars are. Now, we talked about supernovas. Usually it's when a star dies. On the rare occasion that a star collides with another star, you can also get a supernova. They're rare, but when stars collide, you get huge explosions like that. So you can force a supernova. This is kind of what Markiplier was doing when I watched him do this stuff. He was just kind of colliding planets and stars and things like that. But yeah, that's what happens when you have a star collide. It's the same thing. It's a different type of supernova. There's type 1a and there's type 2 supernova. This kind of stuff happens all the time. So stars are born They're not physically born like a human, but they, they form, they live their lives, and then eventually they die. What's the maximum temperature of a star? That is a good question. Let's go back to our HR diagram. Hypothetically, we're looking at about 40,000 degrees Celsius on the surface. Let's see, if you don't use Celsius, let's see. I'm so used to using Celsius, I'm sorry. If you don't use Celsius, so that's about 72,000 degrees Fahrenheit on the surface. That's kind of approaching the maximum of a star's temperature, because that means the core is super, super, super hot and burning through fuel very, very fast. That's the other thing we didn't really talk about, star life. When you look at this chart again, these blue stars, they don't live very long. They burn through their fuel. You know Celsius? Okay, well then, yeah, so that's what's at the bottom here. 30,000 degrees Kelvin, which is basically Celsius. Don't worry about the differences. So about 40 to 50,000 degrees Celsius on the surface. That's about as hot as a star can get. That means a star will not live very, very long. The flip side is, if it's one of these red-colored stars, it would live a very, very, very long time. Stars like Wolf 359 will live billions of years. Our sun is supposedly about 5 billion years old, with about 5 billion years of hydrogen left in its fuel tank before it starts turning into one of these giant stars. So we got about 5 billion years to get off this planet and find a new place to live. Let's go back to this. So we have stars being born, stars dying, and the cycle renewing itself, all in that cloud you see back there. It's called the Milky Way. The Milky Way is a spiral galaxy, and it likely looks something like this. Here you see the spiraling arms of the Milky Way. What color do you see prevalently on the outside? The younger, hotter, bluer stars. As this rotates around, it forces these gases and dust to kind of collide with each other, and that's how you get these stars to coalesce and form and ignite. So you get younger, hotter, bluer stars along the edges of a spiral galaxy. Older, redder colored stars going to be floating around the core, what's believed to be a supermassive black hole sitting right in the middle of the galaxy. But this isn't what we see at night, is it? Why? Why don't we see the Milky Way as a spiral at night? Well, you have to remember, we orbit around the sun, which happens to be in the Milky Way, out along the edge. During our summer months, we're looking towards the core of the galaxy. During the winter months, we look towards the edge of the galaxy. But the galaxy itself would look something like this, like a big whirlpool in space. But it's not alone. When you look at galaxies, you must look at galactic clusters. Our Milky Way is in what's called the local group. There is a local group of galaxies. The Milky Way, if you live in the southern hemisphere, you've probably seen the large or small Magellanic Cloud, named for Magellan, who didn't discover them. He just happened to be the first European to see them, so they named it after him, even though Aborigines and many, many, many people of South America and in Africa had seen these things for a very long time. We still today call them the Magellanic Clouds. They are little chunks of galaxies left over after the Milky Way consumed something. Now, 2.25 million light years away from the Milky Way is another large spiral galaxy. This one's called the Andromeda Galaxy, and it is located up here. Now, a light year is the distance light can travel in a year. At the speed of light in space, it's 3.00 times 10 to the 8th meters per second. It's near instant for you when you flick the light switch. At the speed of light, it takes about 8 minutes or so, a little bit longer to get from the sun to the Earth. About 4 minutes to cross the entire solar system. At this distance, we're talking millions of years just to get here. Andromeda is slightly bigger than the Milky Way, and in space, the bigger you are, the more mass you likely have, and if you are more massive, you have more inherent gravity, which means you are going to pull on things. So you have one big galaxy pulling on a smaller galaxy, and they are pulling towards each other. Andromeda on top, the Milky Way being a submissive bottom in this case. This is the end of our Milky Way. In millions of years' time, our Milky Way will merge with the Andromeda Galaxy. You don't have to worry about that right now, but this is what we believe the physics shows us, the astrophysics, that these two galaxies are going to pull each other towards each other and eventually collide. Now, are they going to physically hit each other? Not really. There's a lot of space between stars. But the gravity of these objects will pull each other apart. Stars will be thrown out into... Look at all these stars getting chucked out into space. Just all by themselves. In the nothingness. Meanwhile, up close you see the core of each galaxy trying to fight for dominance. Right in here. Thought I saw somebody walk by. Hopefully they don't ring the bell because the dog will start barking. But you should ring the bell if you haven't already started following the channel. Please be sure to do that on YouTube and Facebook and Twitch. We're all over the place. Over on Twitter, over on Instagram. Haven't done anything on Instagram, to be honest, just yet, but we will get there. So that is what we are looking at when we look at the Milky Way. This is the core of the galaxy. This will be in the middle of the night tonight. We've kind of walked our way through the sky. Oh god. The sun is back up. Let's look north now. We talked all about some stuff in the southern sky, but we didn't really talk about finding north. North is actually where you find some interesting groupings of stars. You find, again, Orion's one of the easiest things to see in the winter sky during, in the southern part of the sky. But in the north, especially if you live in the northern hemisphere, you see Ursa Major, the Big Bear, particularly a chunk of the Big Bear called the Big Dipper. It is not a constellation, it is an asterism. It is one of the easiest things to see. And just after sunset, it will be where it is here. Now, there's various stories about the Big Dipper. And again, as I mentioned earlier, that Dendera Egyptian chart had these being, the dippers being jackals. But in Native American stories and, First Nations up in Canada, these are actually, kind of spoon-shaped things that bring water. You'll notice that we're entering into springtime, right? And the Big Dipper, which is up here, it's 3 stars making a tail, 4 stars making a cup. Which direction is the cup facing? Well, it's facing down towards the horizon, isn't it? During the springtime, the Big Dipper looks like this. It's upside down. That is the time that it's pouring down water. That is the spring season. Let's keep an eye on this dipper, shall we? I'm just going to leave it like this for now. As the months go along, the Big Dipper will get higher in the sky, and then it will start to get lower in the sky. What months will that correspond with? Well, it's no longer pouring out water. It's going to be more dry months, so the summer months. Again, you can tell what months you're in or what season you're in based on where the constellations and where these groupings of stars are, because they are constant. They do not change. Only the Asteris Planetis, the wandering stars, what we call planets today, those are the only ones that move around. Obviously, a planet is not a star. Stars will twinkle. Planets don't twinkle. You see, the Big Dipper gets low to the horizon. These are the months where the Big Dipper will be collecting water. These are the dry months. And then again, months will pass and the Big Dipper will start to show up again up here, above the horizon, really, really high up. Those are going to be the wet months again. But you do see this every night, because these constellations in the extreme north, they do not set. They are circumpolar. Circumpolar means they circle the pole. The pole, the North Pole in this case, is denoted by the North Star. Now, the North Star is not the brightest star at night. That is the star Sirius. The North Star, or Polaris. How often do you stream? Normally I stream Monday, Wednesday, Fridays, unless there's some extraneous circumstances. Unfortunately, last week I only got to stream once. But I do stream all the time, and if you miss a stream, YouTube keeps them up because since I'm live streaming there, it just kind of shows up as a video. Twitch keeps them on for a few weeks. YouTube seems to just keep them on forever. So if you miss a stream, feel free to click on one of those. I also stream whenever something important happens, like when the Mars rover landed. We did a live stream watching that. Where was I? Ah, yes. Polaris. How do we find the pole star? How do we find the North Star? If you can find either the Big Dipper or a three shape, this three shape over here, we call it Cassiopeia. She's a queen who was very vain and angered some deities and the sea nymphs. They tied her to a chair and tossed her up into the sky. You'll notice she has a mirror in her hand. Since she's so vain, she's so pretty till she's upside down and all of her, you know, nose is running and all this terrible thing. But she looks like a 3 or a W in the sky. These are the two shapes we need to be able to find, okay? Let's start with the Big Dipper. The Big Dipper, again, 3 stars making a tail. And then you connect up here, you make the 4 stars of the cup. Super easy to find. These last 2 stars, we call them the pointer stars. They are about the width of your palm apart. So if you're able to hold your arm up to the sky, you should be able to put 1 star on the left side of your palm and the other one on the right side of your palm. These 2 stars right here. You draw a line through them, and you will go directly to Polaris. That star right there, that is the pole star. That is the North Star. Some people even call it the Lode Star. As you watch, we're going to get rid of the atmosphere. As you watch, the stars will completely circle the pole, circumpolar once again. The North Pole of our planet points a little bit off from it, but it's pretty close to what we call Polaris, the North Star. The other way of finding it, again, is using Cassiopeia. You'll notice Cassiopeia looks like a 3 or a W, depending on where she is in the sky. It doesn't matter where she is, as long as you can draw a triangle, 2 triangles out of her, you are able to find the North Star. So if you could find this triangle here, the equal-sided triangle, draw a line through it, you'll find Polaris. You can also do it with the flattened-out triangle. Draw a line through it, you'll find Polaris. Once again, the Big Dipper and Cassiopeia are always opposite of each other in the sky. So if you can't find one, find the other, and then draw a line through it to the other side of the sky. When the Big Dipper is in the west, Cassiopeia is in the east. When the Big Dipper is in the northern sky but really low, Cassiopeia is really high in the sky. So pick one of them and find your way to the North Star. As you can see, stars are rising and setting all around, but Polaris seems to be sitting in the same exact spot. Fun fact, Polaris has not always been the North Star. There's a star called Thuban. It's actually this one down here. This is Draco the Dragon. It's right around the Little Dipper, which is the little bear in the sky. This star, Thuban, that used to be the North Star. Over time, the Earth kind of wobbles and points towards different stars. Now, it won't be during our lifetimes. It takes about 26,000 years, maybe a little bit longer, for this wobble to happen. But this used to be the North Star. Now the North Star is here, and it'll eventually wobble back around this way, back to this, Thuban, and then back to Polaris. Back and forth, till, of course, the sun gets angry and gets bigger and eats us all. If you haven't already done so, always bring a snack when we do these shows, and always bring some water. You know, hydrate yourself, or bring a tea, or preferably a sugar-free soda. Have yourself a drink, have yourself a snack, open your mind, and just kind of relax. Let the universe in. It's all right. When you look at the stars at night, you are looking back in time. That is actually one of the hardest concepts to understand. Light takes time to get here, as I mentioned earlier. Light filters through our atmosphere, we get this beautiful glow, but you'll notice it does take time after the sun goes below the horizon for us to go into pure darkness, what we call sunset, or in the morning, sunrise. Takes 4 minutes, give or take, for sunlight to get here. But what about all these other stars? They're all different distances away. We can measure the distances to stars by a couple of different methods. One of them is just watching the star as it wobbles around. If it has a planet around it, it will wobble slightly. We can tell the planet's size, and we can kind of tell how far away the star can be through that. There's another thing that's called blue shift. You hear a blue shift all the time. If you have the ability to hear, you can sometimes hear when a police siren or an ambulance goes by. You hear it getting louder as it gets closer to you, and then getting quieter as it goes away from you. That is blue shifting. When it's coming towards you, it gets louder. In the case of stars, they turn bluer. As they go away from us, they turn redder. The wavelength increases. They turn more red. There's also a thing called parallax. You see parallax all the time. As you're sitting there looking at your phone or looking at your computer, I want you to sit up straight, if you can. And I want you to close your right eye and look at your screen. Now, close your right eye, open your left eye. Do you see it kind of moving ever so slightly? If you don't, pick something further away, maybe a picture on your wall, or hold a pencil out at arm's length. Close one eye, stare at it. Close the other eye and open the first eye. And you see it kind of, the background kind of shifts a little bit. We see that with stars. We can actually see what's called parallax. As we orbit around our sun, we see a slight different angle to the different stars. So we can actually kind of do it's a three-body problem. You do some trigonometry, you make a triangle, and you can determine how far away a star is. But that light still takes time to get here. And that's the thing that always trips me out. And it's always interesting for people when they first discover this. Two important things I really want you to understand from this show. One, you and I are made of the dust of stars. Our sun is not an original star. Our sun is a second, possibly third generation star. A star long ago exploded and left behind material that millions of years later turned into a ball of hydrogen gas that then ignited, which is what we call the sun, and it had little chunks left over. Those were the rocks that became the rocky planets, including our own Earth. In your blood, you have the dust of a star. That's point number one. Point number two, that means you're connected to the universe. Point number three, I guess, is the fact that stars are all different distances away. And because of that, you look back in time. The one thing I always try to end my show on is think about how old you are and how far some of these objects are. Let's say tomorrow is your birthday. If it is, happy birthday. Find a star that is as far away as you are old. I'm going to pick a random star, and we're going to say that it's 30 light years away. It's not. This one isn't. I just picked a random star. We're going to use this for a thought experiment. If this star is 30 light years away and tomorrow is my 30th birthday, if I were to look at this star on my birthday, I would see that star the way it looked the day I was born. Because it has taken my entire lifetime for that particular bit of light to get to the Earth for me to see it. The star's constantly pumping out light. Light is both a particle and a wave. It's not instant. It takes time to get here. So if this star is 30 light years away, you start a clock now, 30 years from now, that light would get here. How will the Earth have changed? How will you have changed? You'll be 30 years older. Will you be married? Will you still live here? Will you live in a different country? Will you be living on the moon? Will we have a moon colony by then? We don't know. But that's the interesting thing. Some of these red giant stars, depending on how far away they are, they may already be gone. And we won't know it till their light gets here. We'll see a huge explosion, and then the sky will change. What happens if you again, thought experiment. If Betelgeuse explodes, It says it's 497.85 light years away. So let's call it 500. That's 500 light years away. If it explodes today, when will we know? We would know, if we round it up, in the year 2521. It actually would be a little bit less than that, but we're rounding numbers up to make it easy. How will things have changed in the next 500 years? How has the Earth changed in the last 500 years? What was the Earth like in the year 1521? You know, you had the Black Death in Europe, and then you had, you know, the Renaissance and things like that. So many things change on our planet Earth. Our lifetimes are so short compared to the awesome length of time, the entirety of the universe. And you yourself are part of that universe. You're connected to it because you are made of stars. You are stardust. And with that knowledge, I invite you to go out and do something new. If you write music, write a song. Pick something about astronomy. Make something up. Make some sci-fi up. Go watch Star Trek. Go watch Star Wars. Go do something fun with astronomy as a basis. Or you could even watch Babylon 5. Who knows? Stargate. The Fifth Element. Go watch something sci-fi. Go read a book. Go paint a painting. Draw something. Do you have an OC character? Are you an artist? Do you make OCs? What would your OC look like if they were living on a space station? Or living on another planet? Give them a space backdrop. Who knows? Maybe you could do something fun. Astronomy's for everybody. And it has a little bit of everything kind of built in. You have math. You have, at least in modern times, you have computer sciences. You have chemistry. You have astrobiology. You have earth sciences, so you have, weather, things like that. Any little thing that you might be interested in likely has some connection to astronomy if you really think about it. Older religions, they're all based around astronomy. Old stories, go find a library with a copy of the Epic of Gilgamesh, which comes from Sumeria. Sumer. Gilgamesh is what we call the constellation Orion. It was also called Osiris by the Egyptians. These stories from long ago. Don't limit yourself to just Western. Go find some stuff out about Japanese star myths, or Chinese star myths, or some of the few that are known about the Mayans or the Aztec. Go read about Stonehenge in England, which was likely a star chart of some kind, a calendar. How many buildings on this planet have been built with the stars in mind, where certain times of year, during the solstices, certain things get lit up, the sun itself appears in certain windows or in certain doorways? Why? Because we look up at the sky and we wonder what in the world is out there. Well, not what is in the world, but what is out of this world. What is out there? We're just little humans on the planet Earth, right? What is truly out there? We see stars that have died. We see stars that are being born. In fact, I didn't even mention this earlier. Remember our friend Constellation Orion right in here? There was one other thing we didn't talk about. We talked about finding Lepus the Hare below him. We found all these other constellations around him. But there's an interesting feature of Orion. Just below the belt of Orion, third star of the belt, just go straight down. There's a little cloud. Look at it through a set of binoculars or a small telescope, and you will see something like this. It'll look more ghostly, though. There won't be any color to it. This is the Orion Nebula. This is an area of space where stars are coalescing. They are, quote, being born. They don't gestate like a human or like any sort of primate. They just kind of ignite. It's a big ball of gas and plasma that just happens to light up. Fusion happens. Nuclear reactions happen. Stars are nuclear energy at a safe distance. around these stars, planets may one day form. Who knows? Maybe things will work out and the biology will work out, and there will be creatures on a planet around one of these stars, and they too will look up. They will see a completely different sky because their sky will be oriented completely differently. And maybe they too will wonder what is out there. How this all get here? I don't know. Cosmologists say there was a big explosion, something called the Big Bang, and over time the universe expands out. As far as we can see, the universe is expanding. Maybe one day it'll stop, and then go back and crush itself. A big crunch. So like a big rebound. Boing, boing, boing. Is that true? I don't know. The time scale of that is huge. The universe itself, 13.5 billion years old. That's how far it would go from one side to the other. We're not in the middle. So, where's the edge? When does it end? Does everything just go black? Does everything just stop? And then no stars exist and everything just goes, that's it? I don't know. Maybe you can write a story or make a song. Draw that. Whatever maybe you're a sculptor. Maybe you can make some sort of sculpture of a galaxy or, whatever. Use astronomy as a basis for your art, for your mind. Think big. Maybe you're a business person. Think big. Don't think profit today or tomorrow. Think long term. Those are always my goals, to get people to think. As I said, we do this every Monday and Wednesday and Friday. Monday and Wednesday, the shows are kind of the same. We just kind of talk about what's in the sky, talk a little bit about where the planets are, and of course, since the moon and the planets move around, we talk about their motion, where they are, how to find them. You'll notice the show has changed over the last few months because Orion has moved, and we'll be talking about new constellations over the next few weeks. Leo the Lion is one of them, Virgo is another, but the most important one probably going to be Scorpius. That really won't be out at sunset until, late May or so. But we'll be seeing it rising up soon enough. If you're out after midnight, you will see the scorpion in the sky. It looks like a J. Literally looks like a giant scorpion's tail. Here we are. Sorry, it's about 3:30 in the morning now. There it is. Literally looks like a big J. It looks like a scorpion's tail. The heart star is a star named Antares, which means anti-Aries. It's red like Mars, but it doesn't move around like Mars. This brackets the core of our galaxy. Scorpius, Sagittarius, the little teapot-looking constellation. All kinds of star groupings around here, what we call globular clusters, existing in this part of the sky. They look very, very different than open star clusters. We'll be talking about them as we go through the spring and summer months. There's another triangle of stars that will show up. We have the winter triangle, which you talked about earlier. Well, there's a summer triangle. And these bright blue stars, they straddle the Milky Way. There's even a star festival in China, in Japan, and in Korea, based around the passage of these stars in the sky. The Chinese name is currently eluding me, but Japanese name is Tanabata, 7th night of the 7th month. So we'll talk about that when we get there. There's a whole slew of things to talk about. And of course, when people ask questions, we can talk about that. Bring some questions to every stream, because I want it to be about you guys. I don't want to just sit here and talk about the same things over and over and over. I want to do that in some respects because I want to drill it into your heads. When you hear things over and over, you repeat it, you repeat it, you repeat it, you repeat it. Gotta go, time zone's different, can't watch right now, it's 11:50 p.m. for you. Well, that is pretty late, you should probably go to bed. I do appreciate you stopping by. It is good to meet you. If you like what we're doing here, share it with your friends. You'll catch it before you go to bed. Or again, if you can't actually see it live, you can catch the restream on YouTube. so you won't miss out. Wherever you are, have a good day. Or evening, I should say. Have a good sleep. That's the proper phrase I should have said. Have a good night's rest. I do thank the raid that showed up. We got a couple of new followers. Getting to 12, thank you for following. Culprit is the one that raided us. Culprit, thank you so much. It's truly appreciated. As I said, we do this every Monday and Wednesday. Friday is more of a news-related thing, so we talk more about what science is being discovered, or at least being reported on. And it's kind of an open line thing, so it relies on all of you to bring questions and comments and wonderings of the universe. So it's kind of like a podcast, but in real time. There's conversation. Us sitting around the fire, drinking tea and coffee and whatever else, and having a snack and talking about the world, the universe, and how we are connected to it. Again, hydrate yourself if you haven't already. Take a couple deep breaths. Always good to take 3 or 4 good deep breaths. Relax yourself. Not just with astronomy, just every day. Just calm yourself down. There's so many things going on in your world. You really want to take a moment to relax yourself and reset. So with that, we're going to end our show here. Thank you so much for showing up. We'll see you next time. We'll see you Wednesday, hopefully. I hope you stay safe wherever you happen to be. A good morning, good afternoon, good evening, good night. We shall see you on Wednesday. It helps when you mute the right thing. Good night, everybody. I love you all. Maiden Wrath, I truly love you.